Greetings everyone, myself Muskan. I am from BSc Chemistry Honors first year. I am here to explain the topic group number 16, that is P block element. Let's start our explanation. Group 16 means oxygen family. It is also known as chalcogens. It consists of oxygen, sulfur, selenium, tellurium, polonium. Group number 16, the oxygen family. Their occurrence, let's discuss their occurrence. Oxygen is most abundant of all the element. It occur in the free state, that is O2, 23% by mass of the atmosphere. It also occur in the form of ozone, that is O3, in the form of mineral as a silicate mineral. Other element of this group are less abundant in the earth crust. Electric configuration of group 16 element is Ns2np3. Trends in atomic and physical property. Let's see its atomic and ionic radii. The atomic and ionic radii of group 16 elements are smaller than group 15 elements. The atomic and ionic radii increase down the group. Let's discuss ionization enthalpy. The first ionization enthalpy, that is I1 of group number 16 element, is lower than the group number 15 elements because electronic configuration of group number 15 is symmetrical and more stable. Let's discuss electron gain enthalpy. The electron gain enthalpy decreases down the group, but exceptionally the electron gain enthalpy of oxygen is less than other elements of the group. This is due to its smaller size of oxygen, smaller size of p orbital, high electron density, greater repulsion felt by the incoming electron. Let's discuss its electronegativity. The element of this group have higher value of electronegativity than group number 15 due to their smaller size of atoms. Oxygen is the second most electronegative element. Now discuss non-metallic character. Metallic character. Oxygen and sulfur are non-metallic, where cesium and tellurium are metalloid. Polonium is however metallic in nature, but it is radioactive. Now discuss melting and boiling point. The melting point and boiling point increase down the group due to the increase in atomic size, increase in van der Waals forces of attraction. Now we see trends in chemical properties. Oxidation state. These elements can show positive or negative both type of oxidation state. For example, oxygen can show -2 in H2O plus -1 in H2O2, that is hydrogen peroxide, and +2 in F2O. The highest oxidation state of this group is +6. The stability of +6 oxidation state decreases down the group due to inert pair effect. Now we see chemical reactivity. Oxygen is the most reactive in the group. Sulfur is very reactive at high temperature. The reactivity decreases down the group. Reactivity towards halogen. All the elements of this group form hydrides of formula H2E, where E is oxygen, sulfur, selenium, tellurium, polonium. The thermal stability of hydride decrease down the group because as the size of central atom increase, the EH bond become weaker and thus break on heating. Reducing character increase down the group because as the size of central atom increase, the bond strength of EH bond decrease. Acidic character, it is increased down the group due to the decrease in bond strength of EH bond. Now we discuss reactivity towards halogen. The element of this group form number of halide in the oxidation state +1, +2, +3, +4 and +6. Hexahalides. Only fluorine form hexahalides. Their relative stability decrease down the group because the size of central atom increase, electronegativity decrease, bond polarity increase, leading to the increase in reactivity or decrease in stability. SF6, SEF6, TEF6. Here TEF6 is less stable, therefore it undergo hydrolysis readily. SF6 is more stable. More stable means most stable, we can say there. Now we discuss dioxygen. Preparation of dioxygen. dioxazine is prepared in the following way. Firstly, we can see by decomposition of oxygen rich compound 2KMnO4. When it is decomposed into K2MnO4 plus MnO2 plus O2, here we get oxygen. Now we another way, laboratory method. In the laboratory, dioxazine is produced by heating a mixture of potassium chlorate and magnesium dioxide in the ratio of 4:1 in a hard glass test tube at 147 degrees Celsius. It can be prepared in the laboratory by the action of water and sodium peroxide. Now we see the uses of dioxazine. We can see industry और कमर्शियल मेथड में इसका बहुत ज़्यादा यूज़ होता है. इट इज़ ऑल्सो प्रिपेयर्ड इन इंडस्ट्रीज एंड कमर्शियल मेथड. द मोस्ट इकोनॉमिकल मेथड फॉर द कमर्शियल प्रिपरेशन ऑफ dioxazine is liquefaction of air followed by fractional distillation. Dioxazine can also be prepared by electrolysis of water containing a small amount of mineral acid or alkali. Dioxazine properties. Physical property, first we can see. Dioxazine is a colorless or odorless and tasteless gas. It is slightly soluble in water, sustain marine and aquatic life. It liquefies at 183 degrees Celsius and freeze at 218 degrees Celsius. Now we see chemical properties. Action on litmus. Dioxazine is neutral to litmus. It is not acidic and not basic. Supporter of combustion. It is not combustible but support combustion. Now we see oxidation. It is a powerful oxidation agent, can oxidize metal, non-metal and other compound to their respective oxide. Now we can see the reaction when sodium is burned in presence of air. It produces Na2O. It also reacts with the non-metals.